Hi guys, welcome to my channel. In this video, we will be solving practice 1 from the Unit 6 Lesson 5 packet. So let's jump in. A 0.098 molar solution of cyanoacetic acid, CH2CnCOOH, has a pH of 1.77. Calculate the Ka for cyanoacetic acid. So immediately I'm looking at this problem and I'm thinking it's very similar to practice problem 1, which was covered in the previous video. So I'm basically going to apply the same technique that I used for that problem. So first I'm going to start by setting up my Rice's table. And I just want to note the thing that makes these problems similar is not the information, it is the task. I am being asked to calculate the Ka based on a pH. That is a task that I've done before. It's a skill that I know that I have. So I'm going to apply the same technique. All right. So starting with my equation, I am going to use the abbreviated dissociation equation because I am working with an acid. All right. Now, one important difference between this problem and practice problem 1 is that I'm actually given my initial concentration of cyanoacetic acid. I don't need to calculate it. So let's plug that in to our Rice's table. My initial concentration of H plus and the conjugate base can both be assumed to be 0. The reaction can only shift right because there are no products present initially. My equilibrium expression is going to be similarly, I'm going to use pH to solve for the concentration of H plus, which is equal to X. So let's do that over here. pH is equal to the negative log of our H plus concentration. Rearranging this, I get H plus is equal to 10 raised to the negative pH, which in this case is 10 to the negative 1.77, which is equal to 0.01698. All right. So I can plug this into my Rice's table. And like I said, at this point, it is not inconvenient to solve for this expression. I don't have to use a quadratic. So I'm just going to do it. I'm going to subtract X from my initial concentration. And we get that the equilibrium concentration is in fact equal to 0.081. So it was a smart decision this time to assume that X was not negligible because it clearly wasn't. So now I can calculate my Ka. I always start by writing my Ka expression. see. As we can see, I messed up in writing my conjugate base. Accidentally included the H. I'm going to fix that. There we go. That's much better. And I get that Ka is equal to 0.01698. I'm going to square it because these two are equal to each other, over 0.0818. Do the math, and I get that Ka is equal to 0.00352. And that concludes practice 1 in the Unit 6 Lesson 5 packet. I'll see you guys later.